Hi, my name's Andrew McLaren, and I want to help you memorize hydrogen bonds and how to identify them. So there's these three atoms, nitrogen, oxygen, and fluorine. They are going to be what forms a hydrogen bond, but they need to have a lone pair on them. And the mnemonic that I came up with is no ordinary force for the NOF. So this is called a bond, but this is actually a part of intermolecular forces, and it's a very strong one. This is a very strong force. So it's not ordinary. It's kind of like special. I kind of think of it as like a Superman kind of force in terms of intermolecular forces. So to really understand this, we need to think about their electronegativities of these things and their size. So these are very small atoms, and they are very strong in terms of their electronegativity, meaning that these things are going to be holding on to electrons. And so there's going to be big partial charges, meaning that we have small distances between these things and they've got big charges. So they're very, very strong. So these things can be thought of as being strong due to their electron affinity and their small size. So if we're talking about intermolecular forces, there's a couple different things that should come to mind. So when I think of that, broadly speaking, I think of polar things versus non-polar. And the polar things are broadly speaking going to be having dipole interactions. But within that category, there's also something called a hydrogen bond. So this is just a strong version of a dipole because they still have two poles. So there's like a hydrogen, which is a positive end, and maybe an oxygen, which is a negative end. So they still have a dipole-dipole interaction, but this is stronger than the other ones due to those factors that we were talking about earlier. So hydrogen bonds are very, very strong. And then if we're talking about these other ones, this might be like your LDFs, those line dispersion forces, or van der Waals. You don't really need to know the difference between the two of those for the AP level, but one basically is like even distribution of charge. One has like a maybe a positive core and a negative outer layer, but geometrically they cancel out on all the sides. So there's like symmetry. But in any case, those are going to be things for like non-polar compounds, and they're much, much weaker. So these things that are further over here to this side, they're going to be stronger, and these are going to be weaker. The stronger things should have like higher boiling points slash melting points. And there's a number of other things that you can talk about, like vapor pressure, etc. All these different things can be related to how strong these things are holding on to each other. So to really drive this home, let's just look at examples of hydrogen bonding. So if you've got water, this is the classical example of hydrogen bonding. You have a hydrogen, and it is next to a very electronegative atom that has a lone pair on it. So because of that, if there's other hydrogens around, they can interact with these things, but they're really, really close. So not only does this thing have a partial negative charge and this have a partial positive charge, but the distance between them is very small. So this is close. These are very, very strong interactions. So we can look at other things like the classic example of NH3. It is capable of doing H bonding because we're seeing something very negative next to something very positive. They're very, very small. So they could hydrogen bond with either another thing like itself, like if you've got another NH3, something kind of like that. There's got to be some interactions between the the partial positive and the partial negative. So they can hydrogen bond with things that also can hydrogen bond, but it needs to be something else that also has a lone pair and a hydrogen on it. So you can have like non-polar things present, but they're not going to be hydrogen bonding with this. So just to clarify, if we have something like CH4, that is going to be nonpolar. And this is much, much weaker in terms of the intermolecular forces. So it's going to be a lot easier to turn into a gas or boil or something like that than something like water. So it's important to kind of know the general spectrum here and why these things are called such strong forces. And if you were to kind of continue along this strength pattern, like the amount of energy it takes to separate two molecules is a lot less than the energy to separate like a covalent bond. So if I were to pump even more energy into water, I could potentially separate it into hydrogen gas and oxygen gas. But that's going to take a lot more energy. So bonds, they are much stronger. So hydrogen bonds are kind of like, they're kind of a bond because they're really strong, but they are technically a force, aka the no ordinary force trick. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.